Hello wonderful person, this is Anton, and this right here is the object in our solar system with the most unique, most unusual, and also most mysterious atmosphere. This is Titan. And today what we're going to be doing is comparing the atmosphere of 4 separate objects in our solar system to try to understand how these atmospheres are formed, but also to kind of get an idea of how unusually difficult it is to terraform something. Specifically, we're going to be comparing Mars, Venus, Earth, and this right here, Titan. Welcome to What the Math. Now, in order for us to actually try to compare these atmospheres, we need to first, try to understand how these atmospheres were formed, at least according to our modern understanding of planetary formation. So we think that Mars, Venus, and Earth actually used to have very, very similar atmospheres billions of years ago. And for the most part, because Mars is dramatically smaller than other 2 planets, it lost its atmosphere pretty quickly due to the so-called gene escape of gases. This refers to the idea of certain gases having a certain escape velocity, and depending on the actual mass of the planet, some gases may not be able to actually stay in that atmosphere. Like, for example, for the larger planets, Neptune, Saturn, Jupiter, and Uranus, they can pretty much keep any gas because their mass is much larger. Earth and Venus can maintain pretty much everything, including water vapor, ammonia, methane, but not helium and not hydrogen, which is why we're losing a lot of helium and a lot of, or at least some hydrogen. And then we have objects like Mars and Titan that can't really maintain water, ammonia, and methane, but to some extent oxygen and nitrogen can actually survive here. And so this is actually why Mars is pretty much barren when it comes to the atmospheric pressure. Venus, however, has quite a dramatic, very, very thick atmosphere of about 90 atmospheres. But for the most part, it's mostly CO2. There's practically nothing else here. Just a little bit of nitrogen, about 3%, and the rest is carbon dioxide. Earth has a lot of nitrogen, 75% as a matter of fact, and about 23% oxygen, and then also some CO2 and some other gases. So in some sense, it's almost the opposite of Venus. And that to us suggests that Venus has gone through some dramatic shift in its history, where essentially it had what's known as the greenhouse runaway effect. A lot of the CO2 from within the Venusian surface started escaping. It didn't really have any chance to be deposited into rocks or into the inside of the planet, essentially, kind of like what happens on Earth. And because it had no plate tectonics and no geological interaction, a lot of this gas eventually came out through volcanic eruptions and through potentially other events, such as the outgassing of CO2 through surface. Now, Earth does have a very geologically active surface, and so CO2 gets to be stored on the inside. If it actually did one day come out, similar to Venus, the actual atmospheric pressure of Earth would be much, much higher than even on Venus, and the planet would be pretty much unlivable. It would be too hot. But then we have our little mysterious Titan. Titan has a tremendous amount of nitrogen as well, and we don't really know where it came from. As a matter of fact, Titan is a complete mystery to us. There are very similar objects to Titan in our solar system. Like, for example, there is Europa that I'm going to place here as well. There's also objects like Ganymede. There's objects like Callisto. They are very similar in both the location around the parent planet and also in their composition, but they don't have any atmosphere. As a matter of fact, they're practically vacuum. This, however, has more atmosphere by mass than even Earth. So let me actually show you what the atmosphere of each of these planets is like if I were to kind of just put it as a separate object. And so here is the actual representation of atmosphere of all of these objects. These two are Earth and Titan. So Earth is basically a rock that's approximately 100 kilometers in radius if we were to collect all of the atmosphere and essentially turn it into a rock. Titan is a little bit bigger. It's about 113 kilometers because it has slightly more atmosphere. And remember, this is for the most part nitrogen, and this is even more nitrogen. There's actually some oxygen in this Earth rock. Then we have Mars. Mars is really tiny. It's only about 18 kilometers. And this particular object is for the most part CO2, carbon dioxide. There's just a little bit of other stuff like a little bit of oxygen, a little bit of water. As a matter of fact, this is like 99% CO2, so this is the most carbon dioxide rock we have. And then we have Venus. And Venus is about 486 kilometers in radius. That's basically the atmosphere of this planet right here. This is kind of, if you were to compare it from a distance, this is what it looks like. There is the Venusian atmosphere, there's the Venus itself. And just like Mars, this is also for the most part CO2. This is all carbon dioxide with some other trace elements. And so the major difference between these four atmospheres is that, well, for one, Mars essentially lost most of its atmosphere due to outgassing, due to so-called Jane's atmospheric escape, and that's the effect I showed you right here. It didn't really lose as much to the solar interaction. As a matter of fact, the solar stripping of the atmosphere that's a lot of scientists often blame on Mars losing the atmosphere was only partially responsible. The major effect here is actually the outgassing due to the small size of Mars, and because a lot of these gases could not simply stay on the surface. So Martian mass is responsible for its loss of atmosphere. Which is also why Venus doesn't actually have that problem. It still maintains quite a lot of atmosphere despite not having any magnetosphere. But interestingly, the actual mass of the atmosphere here is basically the size of a dwarf planet. If we were to combine all of the Venusian CO2, we would get this. And this kind of gives you an idea of how much CO2 actually escaped from within Venus. And for the most part, most of it made it into the atmosphere and became this, giving Venus a ridiculous greenhouse effect. But now we come to the mystery and I guess the more interesting part. So both Earth and Titan have relatively similar in mass atmosphere, and both of them have a lot of nitrogen, which is actually essential for us to have a functional and Earth-like atmosphere. So Titan is already kind of halfway there in being, well, terraformed in terms of atmosphere. So if we were to terraform Mars one day, we would have to find a source of nitrogen to actually deposit it in some way or another. Now we think, at least that's the assumption so far, that maybe Titan actually experienced collisions with comets from the Oort cloud, which is why it has so much nitrogen that other objects don't. And if that's the case, there might be a way for us to somehow collide these comets with Mars and bring nitrogen that way. Because if you look at this again, nitrogen can actually survive on Mars just like oxygen. It just needs to be deposited there somehow. And so that's actually one of the bigger mysteries in our solar system when it comes to atmospheres. Why is it that Earth and Titan have so much nitrogen, yet other objects, other moons and other planets don't? But unlike Earth that also has oxygen in its atmosphere, Titan doesn't. As a matter of fact, there's about 1.6% of methane instead of oxygen. And so in that sense, it's still quite different. If we find a way to somehow introduce oxygen into the atmosphere of Titan, we can actually breathe here pretty easily because the actual surface pressure on the surface is about 1.5 atmospheres. Or in other words, 150% more than it is on the surface of Earth. And that's very, very comfortable. At the same time, Titan also has very, very tall atmosphere. It actually extends all the way to about 950 kilometers in altitude. So it's very, very tall, very highly pressurized, but it's also super cold here. So if we can actually breathe here, we still need to find a way to protect ourselves from extreme cold environments. And for the most part, that's really kind of all we know so far. We still don't really understand how atmospheres form on various objects in our solar system, and we still don't really understand what makes certain moons and certain planets so different from each other. We still think that it's probably due to collisions of various asteroids or comets that may bring different materials to the surface, but that's just a guess. And as a matter of fact, in the last few years, we discovered that even though we assumed that water on Earth was coming from either asteroids or comets, we recently discovered that the water on comets is different from the water on Earth. And so the more recent assumption is that, well, it might actually have always been there. So water may actually be coming from the inside of our planet. And if that's the case, maybe the atmosphere is also coming from there, which means that for us to actually find nitrogen and bring it to Mars, to terraform Mars, we might need to actually find a way to extract it from within the planet. And that of course means creating a lot of technology we don't really have. Now, Mars terraforming is obviously a long-term project. It's actually something that we hope to achieve one day, but right now we don't have really, not even the technology, but we don't even have theories to try to tackle this problem. However, this beautiful object, known as Titan, is already quite comfortable in many different ways, and it does have quite a lot of various fuels on the surface that we can use to produce energy. So in that sense, we actually do need to return back to Titan, we need to return back to Saturn, and we actually have to find a way to study the surface of this moon in order for us to understand what's really happening here and how it came to be the way it is. It's exceptionally unique in our solar system. It's a very mysterious and very interesting object, and it actually is one of the most Earth-like objects in terms of the activities and in terms of atmosphere out there. But on that note, until we learn something else about these objects, including Titan, I guess I'm gonna have to stop this video here. And hopefully you enjoyed this, and hopefully you learned something from it, and if you did, don't forget to subscribe if you still haven't, and share this video with someone who loves learning about sciences and space. I'll see you tomorrow in a video that you should probably watch because you might learn something you didn't know. Space out, and as always, bye-bye. And if you do enjoy this channel, maybe even consider supporting this channel on Patreon because it helps me quite a lot.